In this lecture, we are going to discuss the concept of diversification. Now, I'm sure you've all heard of this before. Diversification is good. Diversify your income stream. Diversify your business. But why? What advantage does this offer? People often say, don't put all your eggs in one basket. This is pretty intuitive. If you put all your eggs in one basket and you drop your basket, or your basket is stolen by a bandit, then you will have lost all your eggs. In other words, putting all your eggs in one basket is risky. As you recall, risk is what we discussed in the previous lecture. In this lecture, we'll look at how diversification can limit risk. Let's again consider a scenario where you have two choices. There are again two stocks, stock A and stock B. This time, both stocks have the exact same return and the exact same standard deviation. Let's suppose, for simplicity's sake, that their returns are both normal, with mean mu and variance sigma squared. Importantly, let's also suppose that the returns for A and B are completely independent. As you know, independence also implies no correlation. So the question is this: should you choose to invest only in stock A, only in stock B, or half in stock A and half in stock B? I'll give you a minute to think about it, so please pause the video until you think you have the answer. Okay, so let's look at how to answer this question. First, note that whatever choice you choose, you will always have the same expected return. If you only invest in stock A, your expected return is mu. If you only invest in stock B, your expected return is also mu. If you invest half in stock A and half in stock B, then your expected return is 0.5 times mu plus 0.5 times mu, which is still mu. But what about the risk? Again, we will use standard deviation as a proxy for this. The variance, if you only invested in stock A, is sigma squared. If you only invest in stock B, the variance is still sigma squared. The variance if you invest half in stock A and half in stock B is a little harder to calculate, but you should be able to prove each step yourself. Let's start with the answer, and then we can talk about how it's calculated later for those who are interested. So the answer is that the variance of your investment, if you put half in stock A and half in stock B, is only 1/2 sigma squared. That is, the standard deviation is sigma divided by the square root of 2. So what have we shown? We have shown that even if we have two stocks with the exact same expected return and the exact same variance, and even if investing equally in both stocks yields the same expected return, it is better to invest in both because it results in smaller risk. The variance goes down by a factor of 2, and consequently, the standard deviation goes down by a factor of root 2. This is just another example of not putting all your eggs in one basket. Because the stocks are assumed to be independent, if one stock goes down, it says nothing about what will happen to the other stock. In this optional part of the lecture, we're going to circle back and show why the variance of the split investment is reduced by a factor of 2. You probably want to be comfortable with this kind of calculation, since basically all of portfolio optimization has to do with calculations just like this. Okay, so let's start by saying x1 comes from a normal distribution with mean mu and variance sigma squared. x2 also comes from a normal distribution with mean mu and variance sigma squared. Let's also write down that x1 and x2 are independent, otherwise these calculations would be more complicated. Next, let's say we have a new random variable y, which is half of x1 plus half of x2. Our job is to find the variance of y. There are two ways of doing this. The quick way is this. Recall that the variance of a constant c times a random variable is c squared times the variance of that random variable. You can prove this yourself using the kind of math I'm going to show you very shortly. Furthermore, we know that if two random variables are independent, then the variance of their sum is just the sum of their variances. So in effect, we get that the variance of y is 1/2 squared times sigma squared plus 1/2 squared times sigma squared. The result is 1/2 times sigma squared, as mentioned earlier. Therefore, we have shown that by splitting up your investment equally between two independent stocks with the same distribution, we have reduced our risk. The slow way of finding the variance of y is this. So for those of you who don't want to take my word for any of the identities from the previous derivation, this is more of a step-by-step process. Okay, so let's start by writing out the definition of variance. It's the expected value of y minus the mean of y, all squared. Note that the mean of y is just mu, which is the mean of our two assets. Note also that there is an alternative expression for the variance, which is easy to derive. The first step is to expand the square. We get y squared minus 2y times mu plus mu squared. Next, we separate the expected value of each term. Note that the 2 and the mu are constants, so they can be brought outside the expected value. Next, note that the expected value of y is just the mean of y, which we know is mu. So we get the expected value of y squared minus 2 times mu squared plus mu squared. Of course, that's just the expected value of y squared minus mu squared. Okay, so this is a more helpful expression of the variance for the purpose of this lecture. Next, let's replace y with 1/2 x1 plus 1/2 x2. And again, the next step is to expand the square. We then get 1/4 x1 squared plus 1/4 x2 squared plus 1/2 times x1 x2. Okay, so the next step is again to separate out the terms in the expected value. As usual, the constants can be brought outside. The interesting part of this step is that x1 and x2 are independent. Therefore, the expected value of x1 times x2 is the expected value of x1 times the expected value of x2. As you know, these are both mu. So in the next step, we just get 1/2 mu squared. We can combine the two mu squared terms together to get minus 1/2 mu squared. The next step is to factor out the 1/4. Note how we get 2 times mu squared. The next step is to simply give one of the mu squared terms to x1 and to give the other mu squared term to x2. Of course, this is just the variance of x1 plus the variance of x2. As you know, these are both sigma squared. So we get 1/4 times sigma squared plus sigma squared, and of course that's just 1/2 sigma squared. And again, just in case you forgot what we were doing, we are showing that the variance decreases when we invest equally in two different independent assets. This is even though they have the same exact expected return and the same exact risk. Putting your eggs in multiple baskets decreases your risk.